Okay, hello everyone. This video I want to introduce how to complete in-class assignment 2 and also review head gain calculations. So let's see the summary slides. We already introduced head gain calculation. Like first one for head gain class. So head gain class include both the solar head gain formulas. The first one is a radiation, and the other one is a conduction or transmission. So radiation, radiant solar heat gain. We need the first one to find. We have to firstly to find SHGF as solar heat gain factor. So depending on the direction of the wall or glass, depending on the time, daily time, so we can find the SHGF. And A is area, glass area, shading coefficient. That's also find from table. And the conduction. So solar heat gain from conduction. And from glass is UU factor of glass, area of glass, and delta T. Delta T means the dry bulb temperature difference. And the walls, roofs, we will use conduction, the same as similar to the conducted glass heat gain, but the difference is ETD. ETD is different with delta T. ETD, that means for the direction of the walls, they have the different ETD. So you also need to find it from table. Like first one, you need to know what's the types of the wall and what's the direction of the wall, and then you can find ETD. And internal heat gain include lighting, appliance, and people. And the lighting, so for the words like W, let me for the W words, TS, okay, 3.4 BTU per W. So like when you want to know what's the design heat gain from lighting and appliance, so you need first know how many total watts and then use a 3.4 BTU to buy the total watts. And for the people, you need to know the number of people and what's activity of the people in this room or in this building. Like for sitting, standing, light work, they have the different activity, and for the different activity they will have the different total heat gain. So for per person, what's a total heat gain for per person, and by the number of the people you can get the total heat gain from the people. And latent heat gain and sensible heat gain, the both of them depending on the CFM. CFM, and that means include the infiltration and ventilation. Like we have to address outside unconditioned air go inside, and the unconditioned air go inside, they involve latent and sensible heat gain. So that's for the summary of the heat gain calculation. Let's review the questions. Review the assignment in class activity 2, building design information. So first one, the design condition inside is 70 Fahrenheit and relative humidity is 50%. Outside 95 Fahrenheit dry bulb temperature, 79 Fahrenheit wet bulb temperature. And time, here is time, is August 4 p.m. So based on design condition, you can complete the next one, this table. So here the table is your in-class assignment 2. So you will fill out all blanks. So based on design condition, you can finish this table. So you can stop this video and then fill after the 6 blanks. So what's the design temperature is a dry bulb temperature outside. Outside wet bulb temperature. Inside interior dry bulb design temperature. Inside relative humidity. And design time of day 4 p.m. Design month August. Fill out 6 of them. So you can stop video and fill out them. Now you finish the 6 blanks. Let's start rest of them. First one is war. Let's go this one, this slide. So I put all required information and table psychrometric chart on the hate gain. You can find hate gain slides on Canvas. You can use this slide to complete this assignment. I also put the required information on the first page. You also find them, but for tables, you have to go the slide to find it. So let's see the word. You value based on the given information. We know the word area dark, 4-inch face break, ear space, 4-inch common break. So find the type, ETD, and the U value. So what is a U value for word? Go to the table. This one. We can find this 4-inch face break, ear space, 4-inch common break. This belongs to group L. And what's a U value? This is 0.27. So this one should be 0.27. And how to calculate network area? You can find the separated source north, west, and east. So go to this slide. You also can find from here. So what is height? It's 11. What's long length? There's 50. What's a short side? It's 30. So go to this one. Source, this one, 50, 11, so this should be 50 by 11. This is a gross word. You can find here includes some openings, doors, windows. So you need to minus opening. One door is a 3 by 7 by 7. And how about window? Window is 5 by 5. 5 by 5. And how many window? Total 3. So you can get how many area, how many square feet for source word area. And same at the north. The north is here is for north. This one is for north, and for the source is this one. Source include 4 windows. And what is the gross word area for source? 50, 11. So 50 by 11 minus 4 window. Window is 5 by 5, 5 by 5 by 4. You can get how many square feet for network area source. And again, you can complete west and east. 2 windows, 1 door, and 1 window. So this very small building, the long side 50, long side 50, short side 30, 30, and height for both sides, for 4 sides, the height is 11. And then once you can stop the video and then complete the word area calculation. And once you finish, let's start ETD. So ETD, let's go to this table. We'll find ETD. You also can find the same table from the previous slides. So for the ETD, first one, you need to know what is a group. So based on the material of the word, we know the group is L. So go right here, group L. And what's the time? This 4 p.m. Design time is 4 p.m. And then go here. This is a word facing, the direction of the word. So E, east, source, S, west, and north. So for the east, ETD is 27, S 19, W 22, N is 14. So you can fill out the ETD from this table, fill out there. And what is a keyword equation? Q is U by A by ETD. So you already know the what area source, so you can use this number. You already finish by this number ETD by 0.27. You can get the Q heat gain from the word source. And the same method for north, west, and east. And once you're done, add 4 of them, you can get the total word heat gain from the total words. So that's an introduction explanation for heat gain calculation from word. And next one, roof. So roof, we need to know U value, roof area, ETD roof. Let's see how to do that. Roof type is a 2-inch insulation over 2-inch concrete deck. Light color, find ETD and U value. So U value, how to find it? From table. Let's see. You also can find from here, roof, 2 insulation over 2-inch concrete. So that's one, 2 insulation, 2-inch concrete. And what is U? 0.122. Okay, you can put right here. And what is the roof area? 4 p.m. This color, this type of roof. What's the color? It's light color. Light color. So 43. ETD 43. What's the roof area? We know the building, the long side is 40, short side is 30. So area of the roof should be 40 by 30. That is a roof area. Long side by short side, you got the roof area. And what's a roof equation? Same as the or we already know U by A by ETD. And then you can get the what's a total Q for roof. So stop video, finish roof, and then let's start next one. So next one is a glass. So glass, for the heat gain from glass include 2 types of heat gain, the conduction and solar radiation. So from here, include 2, radiant solar heat gain and conducted heat gain that have the different equation. So let's first fill out the equation. Like solar is Q is GF by A by SC. And how about conduction? Q is U by A by delta T. Let's find some information to complete the calculation. Like the first one, glass U value. From given information, glass U value is a 0.9, shading coefficient is a 0.6. 0.9, coefficient 0.6. And then what do we need to do? The glass area source northwest east. Go to this one. Okay, this elevation view. Source glass, window glass. This window. We also can call this window. Source is 4 windows. 4 windows area should be 5 by 5 by 4. So you can know. Sure. And same as a north, north is a 3 window, 5 by 5 by 3. And how about west, 1 window, east, 1 window. Okay, so fill out the glass area for rest of them. And then let's start the SHGF. So SHGF you have to find from table. Like this one. This for the window SHW. Okay. Go back. Let's switch. Okay, right here it is large. You can see clear. So the month is August, and the time daytime is 4 p.m. So you can find from this row. Okay, this row, August 4 p.m. from this row, and north, east, south, west you can find from the column. So this row 4 p.m. you can find north ETD 23, not ETD, SHGF is 23, east 216, south 40, west is 22. So fill out this number on the 4 of them. So once you finish, we can calculate glass solar heat gain for the source direction. SHGF you can find from this table. A area, this one. Shading coefficient, this one. So you can finish solar source heat gain. And north, find solar heat gain factor north, this one. A area, this one. Solar shading coefficient, this one. Okay, once you finish 4 of them, you can fill out this one, total glass solar add 4 of them, finish this one. Okay, stop video. Okay, now let's start glass conduction. Glass conduction equation is U factor, area is the total glass area, delta T. So why now we can directly use total glass area for the 4 directions? Because we just consider dry bulb temperature difference between inside and outside. So we don't need to separate them. For conduction, just use a total area of glass or total area of windows. U factor 0.9. Area, add 4 of them. Delta T, dry bulb temperature difference. Do you remember you fill out exterior, outside dry bulb temperature? Go here, 95. How about inside dry bulb temperature? 70. So what's the delta T? 25. And then you can finish this blank. UA delta T, finished conduction glass. And what is a total glass heat gain? Total glass heat gain is a total glass solar heat gain you find from this one and then plus this one. So total glass conduction heat gain. So this one plus this one, you can get the total glass. So stop this video, finish all of them. And then let's introduce how about doors. How to calculate doors heat gain? Let's see right here. The given information, the door U factor is 0.11. And ETD already provided. ETD north is 21. East is 28. You can directly find given information. And how about door area? Again, go back to the elevation view. So north only have the north and east have the two direction have doors. So only have one door for each side. North is 1, east is 1. What's the size of door? 3.3 by 7. 3 by 7. 3 by 7. So 21. And same as the above. And how about door equation? Same as the words we used. U by A by ETD. Okay, ETD is difference for north and east, so you have to separate to calculate it again for door north and east. U is 0.11, A is like for north, A is this one 21, ETD north is 21, and for east, U same 0.11, A is 21, but ETD is different. ETD east is 28, so fill out this blank. And what's a total door? Total head gain from door at both of them. Okay, stop this video and complete the door head gain calculation. And then let's introduce internal head gain. Internal head gain include lighting, people, and appliance. So first one, let's see how about the people. The given information people is occupants is 10 people doing standing light work. So how many BTU? Like this one, for this one, number is 10. And per BTU per person, how to find? From table, based on the activity, you can find how many BTU. Standing light work. Okay, this one, standing light work. How about total heat? This is 450. So you can put the 450. Like when we introduce the head gain from the people, you have to consider sensible plus latent, because like we introduced, put your hand close to your nose, you can find like several minutes later you can find some moisture on your hand. So this should be include the phase change and no phase change, temperature change and no temperature change. That means include sensible heat plus latent heat. So find the total heat adjusted is 450. And how about the total heat gain from the people? You have to use the number of the people by the BTU per person. You can get the Q people. And how about the lighting? The lighting from the given information, we need to know how many total watts. Like 30 fixture with a 260 W lamps each. So the total watt is 30 by 2 by 60. You can get the total watts. And the BTU per watt is 3.4. Given information 3.4. And Q lighting, use this number, you calculated the total watts by the 3.4. You can get the total lighting. Heat gain from lighting, total heat gain from lighting. And next one is appliance. So given information 2 watts per square feet. And area of the floor. What is the area of the floor? So again, go to the elevation view. We know the long side is 50, short side is 30. So, like the building, you know, long side and short side. The floor side is same as the roof side. So the roof side, long side is 40, short side is 30. You already finished for the roof area calculation. So floor area should be same as the roof area, especially for the flat roof. And this building is very small, so 50 by 30 is a floor area. And BTU per watt, we already provide is 3.4. And then, so what is a total Q for appliance? Total watts, like 2 by floor area, you can know the total watt. and BTU per watt is 3.4. So total appliance 2 by 50 by 30 by 3.4. You can fill out the total heat gain from appliance. So now you can stop video and fill out 3 of them. And then let's finish last item, the air heat gain air. Like when we introduce air heat gain, we always mention it's unconditioned air from outside. So when we introduce the heat loss, so what is infiltration and ventilation? That's unconditioned outside air go inside through the gap between wall and window, the wall and doors. And also ventilation is based on number of the people and what's the activity of the people. Like we help use the ventilation to provide comfortable indoor air quality for people. So when we want to know what's air heat gain, we need to first know the total CFM from infiltration and ventilation. So first one, how to calculate infiltration CFM. ACH, air exchange, ACH 1.5. Air volume. Air volume is the building volume. Building volume is long side by short side by height, 11. So you also can find all information from this elevation view. Long side, short side, long side, short side, and height. So you got the V. And CFM equation I provide here. V by ACH divided 60. This same as heat loss we introduced. Heat loss infiltration we already use it. V is the volume of the building or roof. ACH air exchange Y60. Because air exchange per hour, H is per hour, but CFM is a cubic feet per minute, so we have to divide 60. And then you can calculate CFM for infiltration. So air exchange 1.5, you got the cubic feet, CF cubic feet, V right here. So finish CFM. And then let's start ventilation. Ventilation, we know the total people is 10. And the ventilation rate we already provided is 20 CFM per person. So CFM, what's the CFM equation for ventilation? People by 20 CFM per person. And then you can know what's the total CFM ventilation. And how about the total CFM? Because we will adjust the total outside unconditioned outside air go inside, right? So this include infiltration and ventilation. So total CFM you have to add this one and this one. So add both of them, you got the total CFM. And once we finish the CFM calculation, okay, I will adjust later. So when we get the infiltration calculation, infiltration ventilation CFM calculation, we can finish the rest of the 2 tables: latent air heat gain and sensible air heat gain. GD, what's a GD? We can find from psychrometric chart. Okay, let's first to see the latent equation. Latent equation Q is CFM by 0.68 by GD. Okay, and how about sensible? Q is CFM by 1 by delta T. Okay, so this one CFM is a total CFM. And what's a GD? Go to psychrometric chart. Okay, let's this one. Outside, what's the outside feature? Dry bulb temperature is 95 and wet bulb temperature is 79. You can find from the first table we fill out from this provided from building design information. So 79 wet bulb, this one is wet bulb, dry bulb is vertical, 95. We got this point. Okay, and then go right way. It's 125. Right away, what is horizontal? Horizontal line is humidity ratio. Okay, it's 125. And how about inside? Dry bulb temperature 70. RH 50. This one is RH. We got this point, and go right away. Around 55. Humidity ratio. So what is a GD? GD is a difference of the humidity ratio, 125 minus 55. Okay, so 25 minus 55, you got 70. So make sure you know how to read the psychrometric chart and then calculate latent heat gain. And sensible heat gain is easy. Like CFM is a total CFM, you already finished infiltration plus ventilation. And delta T is dry bulb temperature difference. Like outside, dry bulb temperature 95, inside is 70. So dry bulb temperature difference, delta T is 25. So you can calculate sensible heat gain. So once you're done, you need to answer the final question. What is total heat gain? Total heat gain is a total heat gain wall, total glass, roof, door, latent, sensible, people, lighting, appliance. So how to calculate them? You can find the yellow mark. Okay, the yellow mark. Add all of the yellow mark. You can finish total heat gain.